Okay guys, so we're looking at solving linear programming. This is number 1 on your homework tonight. We did some problems the other day where we had word problems and we solved for toy, cars, and trucks. So we've kind of gone through this process. We're just backing up now and getting practice with the skill without the words. And then tomorrow we'll add the words back into it. Alright, so the first thing we're going to do is to find the cost represented. If the cost is represented by this equation, then we're supposed to find the minimum cost if these are constraints. And I remind you that a constraint is a restriction or a limitation, and these are the limitations. So I can see this system of inequalities. I'm going to graph them. So you immediately notice the first inequality is not ready to graph, so we're going to graph it. Set it up into y equals, or actually y is less than or equal to. Alright, now I went ahead over to the side here and I graphed that, negative x plus 5. Of course I start at 5, down 1 to the right. Solid line. And which way am I going to shade that? Correct. Yes, sir. Yep, she's not there. Alright, so that's the first inequality. The second inequality is right here. X is greater than or equal to 2. I remind you that that's a vertical line. So I draw a vertical line at x is 2. And of course I'm going to shade to the right because all of those are bigger than that. So that's my vertical line. Now you can already see the intersection is this little triangle right here for just 2 restrictions. But I do have one more restriction, so we're going to get it also. Now the blue one, y equals, that's a horizontal line. So I'm going to come over and make a horizontal line. Make a horizontal line at 1. And shade all of those up. And what I'm looking for is where they all 3 intersect. And if you look closely, there's orange and green and blue in this little triangle over here. And that's the most important part, is identifying that range, that fence where everything is. Once I know that, I'm going to identify the actual 3 corners of that. So those 3 corners are 2, 1, 2, 3, and 4, 1. Alright, and that's just these 3 corners. Now to find the actual minimum cost, we're going to use this function and these points. And we're going to find out that the minimum cost must happen at one of those points. So I take that function and I'm going to plug these points in to the function to find out which one is going to give me the smallest value. So you can see all I did was set up all 3 of them, and then I'll do one at a time. When you plug in 2, 1 here, the x is 2, the y is 1, you get a 7. When I plug in 2, 3, you get a 13. You can double check that. And when you plug in a 4, 1, you get an 11. So the answer to the question was find the minimum cost. Well, the minimum is clearly 7. So I write that out. That the minimum cost is 7, and it happens at the point 2, 1. Now, if this were a word problem, like some we've done in the past, then that 2 would represent something, and the 1 would represent something. For example, maybe that's 2 toy cars and 1 toy truck. That's from the example we did the other day. Okay, at this point, all I want to do is kind of summarize some steps. We don't always put things in steps, but these would be the steps that I'm looking at. First thing that we're always going to do is graph the inequalities, whatever they happen to be. Which, of course, graphing has its own little issues. Once we graph the inequality, we'll identify the corners. Sometimes there's more than 3. Then we're going to take those corners, plug them into our function. And then finally, after we plug them in the function, we just need to identify the min or the max, whichever one they're asking for. So I take a moment to read through this a couple times. This is about as the best you're going to get as far as step-by-step. Okay, this is problem number 3. I know you can't read it, but it is problem number 3. The only difference on this problem is instead of cost, it's talking about profit. So we'll be finding the maximum instead of the minimum. But other than that, it really runs the same. I'm not going to talk you through this one. I'm just going to let it play. I encourage you to hit pause and slow down and stop at any time, just to make sure you understand every step. Our first goal is to graph them, so I'm changing the first one. Okay, I know all that graphing went very quickly, but again, you can slow down and double check all that. Clearly the intersection point is this funky looking shape here. It's a little trapezoid. Notice it cut over. So I do have 4 corners to look at. So I'm going to identify those 4 corners. And then I'm going to plug each of those 4 corners into my function to find out which one gives me the maximum value. Alright, I encourage you to hit pause anytime you need to and just double check this arithmetic. But at this point, I hope you can tell that the maximum profit is going to come from the 11. Alright. Hit pause as often as you need to. Go back, write down some questions, and we'll see you in class.